Hello everyone, here are the answers to yesterday's worksheet, the evens. So please pause the video to make sure you have time to check over all of these. Now tomorrow I'm going to post a PDF of all of these problems showing work with the solutions. But for today, I just want you to try your problems again. Email me if you have any questions or join the Zoom meeting later today, if you have any questions. So again, continue to pause the video if you still need to look these over. What I wanted to do before getting into today's lesson was still review some problems where we're dividing with radicals. So go ahead and just copy down for this first one, the 3 over 4 minus radical 5. Pause the video to see which of the following expressions is equal to this. Continue playing though to see this step by step. Since our denominator is a binomial, I'm going to keep that in parentheses. Also, because our denominator is a binomial with a radical, we need to multiply by the conjugate here, and the conjugate becomes 4 plus radical 5. So that's what we want to multiply top and bottom by. Very carefully. I need to distribute the 3 to both the 4 and the radical 5, so we're going to get 3 times 4 is 12, and then we get plus 3 radical 5. Now, because these are conjugates, I don't need to multiply the outside and the inside terms. So I just multiply the first, which is 4 times 4, that's 16. A negative times a positive is a minus, or a negative. And then radical 5 times radical 5 is 5. So we end up getting 12 plus 3 radical 5, and 16 minus 5 will give us 11. So we're getting E for that. But that's the most basic example of having to rationalize a denominator that's a binomial containing a radical. Let's take a look at some more. Again, pause the video to try these on your own, but I really want you guys to pay attention. Make sure you know how to do these. All right, so in A, we have radical 12, and then we have a radical 6. Now, since they're both underneath the radical, I can divide those. So I could say the 6 becomes a 1, the 12 becomes a 2. But notice the 2 is still underneath the radical, and then in my denominator, I get 5. The square root of 1 is just 1, so I get a radical 2 over 5, and there's nothing left to do. Now for B, I can't do anything the way it's written, so I'm going to separate the radicals as radical 3 over radical 2, and then I need to rationalize this. Multiply top and bottom by radical 2. So now up top, I'm going to get radical 6. Radical 2 times radical 2 is just 2. Again, for C, it's very similar to A. I can simplify anything that's underneath the radical. So 7 goes into 14 and 21, so now the 14 is going to become a 2. The 21 is going to become a 3. I have the x cubes. Again, since they're both underneath the radical, they're the same, so they just divide out. And then where do I have more y's? Up top, how many more? 2 of them. So then these both cross out, and what I'm really ending up with here is a y squared. So up top, I have the square root of a 2y squared all over 3 times the square root of 3. What I could do here is I could take this out. So now I really have a y radical 2 over 3 radical 3. I can't leave this radical 3 here, so I need to rationalize. Top and bottom get multiplied by radical 3. So now up top, I'm going to get a y radical 6. And down here, these two get multiplied together, so I'm really getting a 3 times radical 3 times radical 3 is 3, so I get a y radical 6 over 9. And then D is very similar, again, because the 7 and the 35 are underneath radicals. 7 goes into 35, so 7 becomes a 1, 35 becomes a 5. So now I end up with the square root of 1 over 3 radical 5. Square root of 1 is just 1, so I could write this as 1 over 3 radical 5. I still need to rationalize this, multiply top and bottom by radical 5. So now this becomes radical 5 over 3 times, radical 5 times itself is just 5, so we get radical 5 over 15. So just reviewing some more work with simplifying radicals that involve division. Now we saw yesterday that we were taking some cube roots or fifth roots of negative numbers, and we said we couldn't take a square root, an even root of a negative number. We actually can, they're just not going to be real results. So this is where we're going to start to take a look at imaginary numbers or complex numbers. So at the very beginning of the school year, we looked at the real number system. Now our universe is getting a little bigger. We're going to look at the universe of complex numbers. So the complex number system, we're just going to use a C to represent a complex number. But now these are divided up into or separated into real numbers and then imaginary numbers. So if you remember from last year, complex numbers are of the form a plus bi, where a is the real term and bi is the imaginary term. Again, pause the video as needed. All right, so our first example of a number in the form a plus bi is the 6 plus 2i. The 6 is the real term, and the 2i is the imaginary term. They're not always going to look complete like this, where we see definitely a real and an imaginary. If we're just looking at a 5i, what would a be? What would be the real term if it's not there? Could be a 0. So really this is 0 plus 5i. So every number, whether we see both terms or not, can technically be written up in the form a plus bi. But what if we just see the real term? What about just seeing a 3? So all the real numbers we've been looking at so far has had an imaginary part to it, but just like imaginary friends, you don't see them. So technically here, this is really 3 plus a 0i. So the imaginary term is there, we're just not seeing it because its coefficient is going to be 0. But again, pause the video if you still need to copy this down. So what are we going to do with these complex numbers? We're going to add them, we're going to subtract, we're going to multiply, we're going to divide. But before we do that, we need to know where the I comes from. How did mathematicians how were they able to just create this term? Let's see where it comes from. All right, so if we just look at the square root of a positive 64, we know that that is just 8. So where does I come from? If we're not getting a real answer, then we create something and we substitute in a value for it. So if we wanted to look at the square root of negative 64 and we use that multiplication property with radicals, I could say it's negative 1 times 64. Then I could separate this as square root of negative 1 times the square root of 64. And when mathematicians were first exploring this, this is what they came across. So they said, well, I know the square root of 64 is 8. But what could we do with this? Well, let's just call it something. Let's call that I. So really, the square root of negative 64 is an 8, but then we put an I after it. So what they did was they said the square root of negative 1 is I. Well, what this allowed them to do is to come up with different powers of I. So we know the square root of negative 1 is I. We're just going to call I, we'll set that equal to I. But if you remember from last year, I squared, let's see what that is. So if I is equal to the square root of negative 1, I squared becomes a square root of negative 1 squared. Square root and square cancel, so that's just negative 1. So I squared is negative 1. What about I cubed? Well, we could say I cubed is just I squared times I. I squared is negative 1 times I, so that's just a negative I. And then what's I to the 4th? Well, I to the 4th, we could just write as I squared times I squared, which becomes negative 1 times negative 1, which is a positive 1. So this is a little chart to memorize. Be very familiar with it because eventually we're going to look at different powers of I. But I is just equal to I squared is negative 1, I cubed is negative I to the 4th is 1. Notice when it's an even power, it's a number. It's a negative 1 and a 1. But when I is to the 1st or I cubed, then we're looking at I and negative I. All right, so knowing that little chart, let's go ahead and simplify these expressions. We're going to use a combination of the multiplication and division properties. So go ahead and copy down number 1. What we could do here is separate this into the square root of -1 over the square root of 9 using that division property. Well, we just saw on the previous page the square root of -1 is what? It's I. What's the square root of 9? 3. So this is really I over 3, or we could look at this as 1/3 I. Technically, it's still of the form a plus bi. This would be 0 plus 1/3 I. Number 2, anytime we see negatives underneath the square root, we want to take out that -1. So I'm going to write this as the square root of -1 times 6 times the square root of -1 times 12. So I have to take out those -1s. So what's the square root of -1 again? It's I. So I get I radical 6 times I radical 12. Now I'm going to multiply those i's together, so I get an I squared. Then I'm going to multiply the radical 6 times the radical 12. I want to make one large number out of it. So I get I squared times radical 72. Well, I squared, if we go back a page, I squared is -1. So now this becomes a -1, and then I want to simplify the 72. Radical 72, if you remember, is 36 times 2. So now I could take the square root of 36. So this becomes a -1 times 6 radical 2, which is -6 radical 2. But our very first step had to be to take the -1s out because we were working with complex numbers here. If you wish to pause the video, try 3 and 4 on your own, or you can continue playing. So 3, we have -5i times 3i. So what I could do, this is just looking at it like this without the parentheses. I can multiply the -5 times the 3 to give me -15, and then I squared. Now again, we know that I squared is -1, so we get -15 times -1. So because I squared is always -1, anytime we multiply a number by I squared, it's going to turn to its opposite. So this will just give us 15. So it may not always be necessary to write this step right here. Now for number 4, I'm going to write this as -9i times -9i. So if I multiply -9 times -9, that's a positive 81 times I squared. Now what I just said, I squared is a -1, so it's going to turn the positive 81 into a negative. Or we could still show that step. 81 times -1 becomes -81. Looking at number 5, go ahead and copy that down. Here we need to distribute. Again, pause the video if you wish to try 5 and 6 on your own. But for 5, we need to distribute. So 4i times 3 is just like 4x times 3. This is just going to become a 12i. Minus 4i times 6i becomes minus a 24i squared. Now I can't leave any larger powers of I, so I need to take care of this last term. So this becomes 12i minus 24 times -1, which is 12i plus 24. So here's our complex number. The 24 is the real part, 12i is the imaginary part. All of these, again, are complex numbers. Looking at number 6, really what we have in front here, we have a 7i, then we could think of this times a -1i, then times 2i. So I can go ahead and multiply all the coefficients together. 7 times -1 is -7. -7 times 2 is 14. And then I have I times I, which is I cubed. Or we could show this as 14 times I squared times I. It doesn't matter however you want to work this out. But if you go back to the chart, I cubed is -I. So looking at this step, this could become 14 times the -I, which is just -14i. Or looking at this here, this becomes 14 times -1 times I, which is -14i. So you could leave it this way and proceed over here, or you could factor this into I squared times I. Either way, we get -14i. Okay, 2 more examples. Go ahead and copy down number 7. Okay, here, notice we're not multiplying, we're simply subtracting. So this is just one binomial minus another. So I want to remove the parentheses first. The first, I don't have anything out in front, so I could just keep it as 5 plus 3i. But here I need to subtract both, so I get a minus 4 plus 11i. Now it's all about combining like terms. I want to combine the real terms, which is the 5 minus 4, which is 1. Then I have 3i plus 11i, which is 14i. That's all we're doing for this problem. Now take a look at number 8. Go ahead and copy that down. Here we're multiplying, so I need to use a distributive property. First, I multiply 8 times 5, which is 40. Outside, I multiply 8 times a negative 3i, so that's a minus 24i. Inside, I multiply 2i times 5, so that's a positive 10i. And then last, I multiply 2i times a negative 3i, so I'm going to get a negative 6i squared. I can combine my two middle terms, so I still have the 40. Negative 24i plus 10i will become a minus 14i. And then over here, I get a negative 6 times a negative 1. Or if you remember what I said, the I squared is going to turn the negative 6 to its opposite. So you didn't have to write this step here. We could have just said 40 minus 14i plus 6. Now I can add the 40 with the 6, so we get 46 minus 14i. All right, so we're going to continue with these tomorrow. Off of the worksheet today, I just want you to do 1 through 11. You don't have to see the next page. You know, I always post this as a separate PDF. So again, off of this worksheet, when you get this, do these top 8 and then just stop right here. So just do 1 through 11. Everything I show you tomorrow will help us finish this worksheet. All right, so give these a try. Like I said from yesterday's homework assignment, please let me know if you guys have any questions. Take care.